Hello everyone, so we're going to be talking about multiplying radicals. So something that we have with radicals is the product property for radicals, and that tells us that if a and b are real numbers and n is an integer greater than 1, then the nth root of a times b is equal to the nth root of a times the nth root of b. And this really comes from our power of a product and power of a quotient property from our previous lesson. Because remember, the nth root of a, I can rewrite this as saying a times b to the 1 over n power. And we learned that we can distribute that power to be a to the 1 over n times b to the 1 over n, which again is just the same thing as the nth root of a times the nth root of b. So for example, if I have the cubed root of 4 times the cubed root of 2, this would equal to the cubed root of 4 times 2, which is 8. And we know the cubed root of 8 is equal to 2. So we're going to look at writing radicals in simplest form first. So we're going to write each expression in simplest form. So simplifying these radicals is really similar to when we were simplifying square roots. So for example, if I had the square root of 12, we learned that we can go ahead and break this down by factors. So I have 2 times 6 and 2 times 3. Now when we're taking the square root, remember that we took out pairs of numbers, and that's because that index here is really a 2. So here I'd say I have a pair of 2's that can come out, and so I'd put a 2 out in front, and then what's remaining, which is 3, would stay inside of the radical. We're going to follow that same idea for these ones, but now instead of pairs that we're taking out whatever our index is. So for instance, for this first one, I have the cubed root of 135. Since my index is 3, I'm looking at taking out triples of the same number. So looking at 135, I see first I can break this down by 5 can go in there. And 135 divided by 5, I get 5 times 27 is 135. 27, I see that can be broken down by 3 times 9. And then 9 is 3 times 3. So I see here that I have 1, 2, 3 3s. So that means I can take a 3 out. But another way you can think about this is that I can rewrite this 135 to now be 3 cubed times 5. And from our product property, I can break that apart to be instead the cubed root of 3 cubed times the cubed root of 5. And so the cubed root of 3 cubed will just get me 3, and then cubed root of 5. And remember, the reason why the cubed root of 3 cubed gets me just 3 back is because I can rewrite that to instead be 3 cubed raised to the 1/3 power. And when I have a power to the power, I multiply those exponents. So 3 times 1/3 gets me 1, and so that gets me 3. So it's kind of a breakdown of how and why this works. Okay, let's look at number 2. So number 2, I have the 4th root of 567. So first I need to see what goes into 567, and I see that 3 goes in there, and I get 3 times 189. And then if I do 189 divided by 3, I get 63. So I have 3 times 63. 63 can be broken down to be 3 and 21. And then that's going to be 3 and 7. So here my index is 4. So that means I'm looking to see it have 4 of one number. And I see that I have 4 3s right here. So that means I can rewrite this to be the fourth root of 3 to the fourth times 7, because that's all I have left over. So that means I have 3 that comes out and fourth root of 7. Again, you could go ahead and skip right to that last step by seeing that I have 4 3's, so that means that 1 3 comes out. Okay, now 3 and 4, I have some variables that are in there. So number 3, I have the cubed root of 128y to the 6. So here my index is 3, so I'm looking to find triples of something. So I'm going to first go ahead and break down this 128. So 128, I know 2 can go in there because that is an even number. And if I do 128 divided by 2, I get 64. 64 can be broken down to be 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. So I have a lot here. So I have 1, 2, 3, 4, 5, 6, 7 2's. So I'm going to rewrite this in groups of 3. So I have a 2 cubed, so that's 3 2's, 3 more 2's, and then 1 more 2 because I had 7 2's in total. And then I can do the same thing with this y to the 6. So I can break it apart in 2 groups of 3. So I have y cubed, y cubed. And so that means I have the cubed root of 2 cubed times the cubed root of 2 cubed times the cubed root of 2 times the cubed root of y cubed times the cubed root of y cubed. Well, the cubed root of 2 cubed is just going to be 2 times 2. And then the cubed root of y cubed, again, those cubed root and the power of 3 cancel each other out, so I end up with just y times y. And so multiplying all those out, 2 times 2 is 4, y times y is y squared, and cubed root of 2. Another way you can think about it for that y to the 6 is just equal to y times itself 6 times. And so looking for triples there, I see I have 1, 2 triples. And so that's why a y squared comes out of the radical. Okay, let's look at one last one. So here I have the fifth root of 4a to the 8th, b to the 14th, and c to the 5th. So breaking down that 4, I just have 2 2's, so nothing is coming out there. I need 5 of one number that comes out. But now I need to figure out how many of the a's come out, b's, and c's. Well, if I look at a to the 8th, that's the same thing as a times itself 8 times. And so looking to see how many groupings of 5, since my index here is 5, can come out, I see that I have one group of 5 A's. So that means that one A is definitely coming out, and I'm left over with 3. So I have one A that comes out, and I'm left with 3 A's that are still in here. So what I'm really doing is I am dividing that exponent by 5, and then whatever the remainder is what stays in there. So 8 divided by 5 is 1, so 1A come out, but then there's a remainder of 3. So let's look at for B. So 14 divided by 5, I see that 5 can go in there twice, so I have a B squared that comes out in front. And 5 times 2 is 10, and so that means I have 4 remaining, so that's B to the 4th. Now C to the 5th, I see that is exactly 5, so one C comes out, and there's no C's remaining. And so my answer here is A, B squared C times the 5th root of A cubed, B to the 4th. Again, another way that you can do this is to go ahead and break it apart. So I could do 5th root of 4 times the 5th root of a to the 5th, and that leaves 3 remaining. 5th root of b to the 5th times 5th root of b to the 5th, and that left 4 remaining, because 5 plus 5 plus 4 is 14, times 5th root of c to the 5th. And then when you simplify that out, you get what's above here.